In this video tutorial, we're going to be working with rasters and raster values. We're going to be mapping population density via a population count from NASA. And to do our mapping, we're going to go through several steps. So let's walk through real quickly an overview of the steps that we're going to do. The first thing we're going to do is we're going to download our data as step 1. Step 2, we're going to bring into QGIS and explore our rasters, or I should say our one raster. Step 3, we're actually going to create a geometry column, and I'll explain why we need to do that. So we're going to be discussing planar versus angular units. The fourth step, we're going to run Zonal Statistics, which is a new tool. In step 5, we're going to be calculating a population density within administrative units. And finally, we're going to be thematically mapping our results. So we're going to create a thematic map at the end as our product. And the things that we're really going to concentrate on for this video is first understanding what a raster value is, and then how do we collect raster values into meaningful administrative units? This is kind of a common GIS task, is rasters are continuous values, and sometimes we want to bring those continuous values into a unit that's a polygon unit that's important to us. We're going to learn some new tools, so clipping and zonal statistics. We're also going to normalize for square area. In the past, we've been normalizing for population for census work. In this case, we're going to be utilizing actual square area as for normalization. And we are going to discuss planar versus angular units. We're going to be using a map projection called the Moveda world projection. And we'll also, like I said, do our final thematic mapping, and we'll choose a method, a classification method that works well for our data set. So to get started, the first thing we want to do is download our data sets, and let me walk through those real quickly. So we're going to be using data from the Socioeconomic Data and Application Center, CDAC at NASA. This is hosted at Columbia University. And here's the actual data that we're going to download. So this is the adjusted population count. We're going to use the year 2015. We're also going to be downloading administrative units. So these are just polygons, and they're for each country. So I have a drop down here of all the different countries, or many different countries, I should say. We're going to use one of those countries. I'm going to use Australia as the example for the video, and the reason I'm using Australia is because the population dispersion in Australia is an interesting pattern that can be somewhat challenging to map. So once we get to the final thematic map, we'll discuss a method that we can use that should work well for Australia. We're going to download this. I'm just going to go ahead and do this now. I've actually downloaded it already, so I would just go to Global Administrative Units. It's gadm.org, and then country. So this is what it looks like. So the landing page for this site, let's take a look, is this. And then you just go to download. And you want to choose a country that you're interested in mapping. So I would suggest quote medium-sized country. I wouldn't pick something too small or something huge. Something like Greece might be interesting, Germany. A relatively decent-sized country would probably fit the bill for this particular mapping pretty well. And we're going to download a shapefile. Okay. I've set up a folder, so I'm just going to walk through the folder real fast that I set up. So this is the way I've set up my folder. I'm going to do Australia, so I've called it AU_pop for population. So I have a saved QGIS project right now. I have an exports folder because we're going to be exporting different things, and I have that set up. And you can see I've downloaded my administrative units and also this population count. Now the population count, this is where we get this, and let's walk through this because this isn't exactly easy to do. So this will be the landing page for it, and it describes the actual data set here. So this is a gridded population of the world, meaning it's a raster data set for world coverage. And they have different years. We're going to use the year 2015 here. And the size of the pixel cell is they have several different ones. So it's a 2.5 arc minute, 15, 30, and a 1 degree resolution. Those are degrees, so we're dealing with angular units here, which is somewhat difficult. So we need to think about how are we going to get this into a planar unit, and we'll talk about that just a bit. It's essentially 1 kilometer is the size of the raster cell. So it's going to change depending on what latitude we're at, but at the equator it's about 1 kilometer. So it's giving us a population count that is it's decent. It's not really high resolution, but it's for our mapping. It should work fine. We're going to download the data here off this tab. So let's just go ahead and start that. It's probably going to ask you for a login. So I'm just going to go ahead, and if you'll get to this screen, and then you'll need to do a registration process. So it's just basically email and a password, and then you'll be able to get in. I'm just going to pause the video to log myself in. Okay, so I logged in there. And it'll bring you to this page here. And we need to pick out the year. So I have single year, and then the file format, we're going to use a GeoTIFF. And the resolution is going to be the 1 kilometer or the 30-second product. Once you set this up, then it's going to let you into the years, and we're going to do 2015 and create the download. So this is the download. There's some documentation here, and here's the actual download package itself. I've already downloaded it, so I'm not going to go ahead and click on that right now. So, and of course I have my administrative unit for Australia. I've done that. So I'm just going to go ahead and click out of the browser now. And now I'm just going to unzip my products. So I'm extracting, and then I'm also going to extract my count here. Extract this out. This will take a second. Then what I'm going to do is just quickly put these into the trash because it can get confusing. And then I'm going to come back into QGIS, and I've set up a favorites already in the browser panel. So here you can see everything I have. So let's go ahead and do this. Let's bring in the population count itself. So we're just going to drop this in, and as it comes in, it approximates the values. It gives us an estimate of where the values are at. And if we zoom into some countries, we can see that it's obvious that there's a pattern that's taking place here, but we can't really see it very well. So one thing that we can do real quickly to make this easier on our eyes is we can go to Properties, and under Properties, let's go ahead and do our load min-max values. So here, instead of a cumulative count, let's just go to min-max, and we can even go to actual values and load it. So here it's going to go through the whole data set, and it's going to try to find those values, and it's going to take a second to do that. And so we go from a minimum of essentially 1 to a pretty high. There's one cell in there that has a very high population count. That's this. And then what we can do is we can go ahead and send this to a single pseudoband or pseudocolor, and let's just put it on a scheme that looks something like this. I'm going to actually do equal intervals, and I'm just going to keep it at 3 classes and say apply. OK. And that helps us understand what we're dealing with here. So we can see, as we know that India is very populated, and we know that Asia is very populated also, we can see that these purples are our high population counts. And then Australia is what I'm going to focus on for the video here. We can see that we have some cities with high population counts. And these areas that you see that are kind of blocked off, that there's sections here that just have no value. So we need to be careful when we're when we're working with our raster here that we're aware of no values and null values. So let's go ahead and get started. The first thing we want to do is we have a pretty big raster here, so we want to cut this down. We want to essentially clip it to our country boundary. So depending on what country you're using, your process is going to obviously involve a specific country. I'm going to use Australia for the video here. So what I need to do is go in and I'm going to go to my admin units. And the admin units are divided into different levels. So 0 is the actual country boundary. 1 is usually states. And then 2s and 3s are going to be administrative units underneath states. So something like a county or a commune. And for my final mapping, I'm going to want to do Australia's admin 2 as my final map. But to get started, I just want to use the outside edge of the country. So I'm going to be using the admin 0. So I put that in, and we can see that it gives me a vector feature for Australia. And this is what we're going to actually use to clip our raster now. So clipping of rasters is an important process where we take a big data set and make it more manageable for our particular project area. So what we're going to do here is we just want to go ahead and clip this. So we're going to go to raster, and we're going to extract values essentially. So we're going to go to the extraction clipper, and we're going to input our raster. We're going to output it. So let's put it somewhere that makes sense. So under exports, I'm going to go ahead and put in AU_clipped, and we can use GeoTIFFs for this work. And I want to, not to the extent, I want to put in a mask layer, and my mask layer is going to be my administrative unit at 0. And I'm going to keep the resolution of the input raster, because remember, the resolution is the cell size itself. We'll review that in just a moment here. So I'll go ahead and say OK. And this will take a moment, so I'm going to go ahead and pause the video as this runs. It could be anywhere up to 5 or 10 minutes. I'll let you know how long it takes when I come back here in just a moment. Okay, my processing took about 8 or 9 minutes, so expect it to take a few minutes to process. And I'm going to go ahead and close now. And we can see that I have a new raster that's been produced and clipped out to the boundary of my polygon. So let's put that on top and zoom in a bit here. So we can see what's happening is that it's clipping the raster to the boundary of the administrative unit, which is what we want. And I'm just going to go ahead and get rid of the world file now. So if I zoom to layer, this is kind of what it looks like when we download it. So it's a continuous population count across all land space essentially, and we just want to go ahead and clip out our particular country and do the analysis on the country that you choose. So I'm going to get rid of the original file at this point, so I'm just going to go ahead and remove that, and then I want to go ahead and save it now. So I'm saving my project. And I could create a spatial bookmark and kind of get ready, because our final map is going to be a country. I'm not actually going to do that. I'm just going to save the project here and kind of start setting up here for the next steps. So let's make our administrative, we actually don't need the administrative feature, so I'm going to put that on the bottom. Let's explore our raster at this point in time. So if I go down to properties and go into general, I can see that its coordinate system is currently at WGS 1984, so its units are going to be angular units. And I can see in terms of its columns, it has about 43,000 columns and about 17,000 rows. It has a no data value. And I can also go into the metadata itself and kind of take a look at the properties a little bit closer. Let's go ahead and do that together. So we can see that it's a GeoTIFF. That's the format that it's in. we can see that we have some basic statistics here. So we have minimums, we have means, we have a maximum. So it looks like our maximum value is 2728. And the pixel size here is currently in degrees, so it doesn't make a lot of sense to us, but it's essentially a 1 kilometer by 1 kilometer cell size. And it also has a no data value. We can see its data type is a float, and we can see its spatial reference here. So it's really important before we start working that we just kind of preview what it is that our actual file type that we have. So essentially what this is translating into is that for each one of these cells here, let's zoom in a little bit closer, each one of these cells in my project is holding essentially 1 kilometer of pixel space that is holding a value. And since thematically my raster is a population count, the number represents the population of people within that kilometer square or kilometer grid. That's the theme of my particular raster. Now there's many different themes obviously of rasters, so we just need to really understand what is it that's being measured before we get too far in any mapping. So since we're dealing with a population raster, that's what it is. It's population per kilometer essentially. Or I should say a population count per kilometer. So let's go to properties and symbolize this a little bit better. So let's do it, let's put some color on it. And this color ramp works fine. I'm going to load in my minimum and maximum values. I can go to actual values and I can load it. And once I load it, it's going to give me a number here. So my top value is about 11,000. And I'm just going to symbolize it. I'll just do equal intervals and 3 class, or I'll just, yeah, 3 classes is fine. And let's see what we get back. So if we zoom out a bit, we can see it's pretty boring. But in Australia, we can see that we have these population centers here right around the coast. And this is what makes Australia interesting, is that it does have these particular cells that are located in these coastal areas that do have a high population relative to the rest of the country. So the rest of the country is pretty much this really low value, but we do have these pockets here, and these are urban areas. And so what we want to do now is we want to actually collect up these values into administrative units that are going to help us make a thematic map that makes sense of this raster. The raster as it is perfectly fine. I mean, it shows us exactly where our population is located. But if we want to bring it into administrative units that's separate of the raster itself, what the steps that we're going to take next are gonna do that process. Okay, so you might be wondering what these blank areas are in the middle of Australia. These are essentially no data values, and you may have some of this in your particular country. And if you want to just check on that, before we get too much further here, I want to show you a tool that you can do that. So if you go up into plugins, there's a tool called the value tool that will allow you to do this. So value, it's this one called value tool. I already have it installed, so I'm not going to install it further. And what it does is it gives you a little information tool that you can go over the top of your raster. So you can see over here in my value tool on the lower left hand side, we can see my values as I pan over. And right, so in the middle of the country it's really low values, and then as I come out to towards the coast, we can see that I get to much higher values. So I'm going to come down here and we're up into the thousands now. But as I roll over this middle area, you can see that I hit no data. So there's no data collected at that particular location. And that's probably because in the middle of Australia, there's probably some features where there's just no population whatsoever, and they just haven't collected it there. So you're going to get some of these areas where there's just no data, and that's perfectly acceptable and expected. I just wanted to point that out before we get much further here. And that importantly, that you can download a plugin tool that's going to allow you to see your raster values in a nice interactive way that's really helpful. So again, that's the value tool. Okay, so we want to be mapping at a polygon, or we want to bring our raster values into a polygon. We're going to do this at the admin 2 level. So if I click on my Australia admin folder, we can see I have admin 0, admin 1 is the states, and admin 2 is a unit below states. So these would be like districts. And I'm going to go ahead and open that up. So here it comes in. So it sits on top of my raster. The issue here, before we get too much further, is that I'm currently in a degree system. So I'm in EPSG 4326, which is WGS 1984. And so if I go to my properties and I look at my general tab, I can see that this is my coordinate reference system right now. The issue with this particular coordinate reference system is that it measures everything in terms of a degree. It's an angular unit. And when we start dealing with areas, square areas, which we're interested in finding out because we want to take our population count and we want to develop a population density per administrative unit, then we need to have actual planar unit. We need to have a square area. And although I'm not going to be spending a lot of time in this video talking about map projections, we're going to do a projection transformation on this particular file so that we can get into actual planar units. Okay, and so the steps to do that, let me bring up my notes here, is we're going to import our administrative unit, which we've done. And then we're going to immediately export it out to Movoide world projection. We're going to bring it back into our project. And then once we bring it back into our project, it's going to be on the fly projection. Okay, so we're going to be able to see it overlay our current raster. But now we can add in geometry columns that are going to be in square units. And then we're going to calculate kilometers or square kilometers, and then we can export out those results back out to WGS 84. Okay, so the process here to do this is not terribly difficult. We just need to make sure that we get the steps right. So we're going to do a right click on the actual feature. We're going to go to Save As. And as we do Save As, we're going to set the CRS, which is the coordinate reference system. Okay, the actual projection, the map, what everything's being measured in. We're going to set it to something else now. We're going to set it to the thing that we want to reproject it to. And we can use this little tool right off to the right hand side to do that. So we're going to select the CRS here. And for this mapping, we can use the world Movede, which is this projection right here. And although this is probably not the best to use for our particular country, this is more of a worldwide system. It does have a meter, and we can see it down here in the bottom under the projection description. We can see that its units are in meters; they're not in degrees. It will do a decent job of getting us the area calculation that we need. If we were to do this mapping for a country, for a very specific country, we probably would pick a slightly different projection that's highly adapted to the country itself. But since we're just doing this assignment and we're just trying to get a rough estimate using a world map projection that is good for equal areas. This is a well-known map projection that handles area well. This will be okay. This is suitable for what we're actually going to be doing for this particular mapping. So we'll all use this for this mapping, regardless of where your country is located. I'll say okay. And now we can see that it's going to send it to a new map projection. And then I'm going to name it, and I'm going to send it to my exports folder here. So I'll go to desktop, onto exports, and I'm just going to call this AU for abbreviation for Australia, and I'm going to call this projected. And say save, and I'll accept all the defaults and say OK. And it'll drop it back in, so it comes back in, and as it comes back in, we don't see anything different, and the reason is because this project has on-the-fly projection currently. So if I go up to project properties, it's enabled on-the-fly projection. That's already been established. Okay. So we go project and save this now. So we're going to update our project. Now what we're going to do is let's get rid of this unit so we don't get confused. This was our original unit, Australia admin 2. We're going to remove that. And now let's go ahead and calculate geometry, or calculate a geometry column within our attribute table here. So we go to open attribute table, and we can see in the attribute table that we don't have a lot of information beyond the name itself. So we have the admin level 1 and admin 0. So admin 0 is the country name. Admin 2, or I should say admin 1, is going to be probably a state name. And then the level 3 is, this is districts, or it's going to be, it could be a county, it could be a commune. It's going to be a smaller unit underneath these two. So admin 2, some countries will have an admin 3, but we can map it to admin 2. But we don't have anything here that's meaningful in terms of square area, and we need to calculate that now. So what we can do is we can go over to vector tools, and we can go to geometry tools, and under geometry tools we can go towards the bottom here and add geometry columns. Okay, so what I'm going to do is I'm going to input this layer, my projected layer. I'm going to calculate the area using the CRS for that particular layer, because remember we've sent this layer, we've reprojected it out to Movaid map projection, and we can use those units, which are meters, to do the calculation. If we were to do this on the original file, it's in degrees, and that's going to give us back a number that doesn't make any sense. So we really want meters. So let's go ahead and do this. I'm just going to create a temporary file and say run it. And if we come up and look at what was produced, which is the added geom info, we open the attribute table here, and we can see now that we have an area column and a perimeter column. Now what's important to realize is that this area column is in meters, and obviously that's a really big number, and we probably want square kilometers. So what we can do is we can create a new column in this. So let's go ahead and do that. We're going to, let's use our field calculator to do that. So I'm going to go to the field calculator, which is up here at the top. And our calculation for square kilometers is basically meters divided by this number right here. Okay, so we'll put this in this calculation. So it's 1 and then 6 zeros. So we're going to go, we're going to create a new field, and the output field name is going to be, I'm just going to call it KM_SQ. And we're going to go to, we can do decimal numbers. And our precision, our output field length can be something like 5, and our precision, let's have a precision of 3. 3 or 4 is fine. And what we want to do now is set up our expression. So we're going to go to fields and values, and under fields and values we want to take our area, okay, and we want to divide it by 1, and then 1, 2, 3, 4, 5, 6 zeros, and that's going to give us our square kilometers. Okay, so we're taking our original meters and dividing by this and saying okay. And as it does that, it puts it into an editing session. And once the editing session has taken form, we can go ahead and say Save Layer Edits. And after it saves it for a moment, we can go back into Toggle Editing Off. And we should have our column now. So if we go into Open Attribute Table and come down here, now we have square kilometers in our column. And we can see that some of these are small. So let's do this. Let's just do a quick little test. So let's reverse it, and let's go get our big square areas. So these are the 16 top. I'm just going to quickly interactively select these. Okay, so that makes sense. These are all very big in the middle of the country, and that seems to make sense intuitively. All right, so now what we're going to do, let's export this back out. So we're going to do a right click and say Save As, and we're going to send it to our exports folder. And now I'm going to call this AU, I could say something like AU Final. I'm just going to call it AU WGS84. So I'm going to send it back to WGS84. Say save it. And I should be able to just find it here. If I can't find it here, I can go back to select the CRS and say WGS84 and say OK. OK. And there it is. So we've done our calculation. So basically what we did is we exported it out to a projection system that could see meters, and then we calculated geometry using those meters, and then we did a field calculation to get us square kilometers. So let's go ahead and remove this, and we're going to remove that one. So this is going to be the one that we want to do the rest of our work in. So we're going to go ahead and say save. And now what we need to do is we have two things. We have a raster sitting underneath a vector for admin2. And admin2, all it does is have square kilometers at this point in time. And it has a name. So what we really want is we want to get our raster values into each one of these polygons. We want to do basically a summary of those values into the polygons. So we're creating a relationship between our raster layer and our vector layer, and that's going to be meaningful for thematic mapping that we can do. So the way to do this now is do a process called zonal statistics. So if I open up the attribute table, what I really want here is I want a column that's going to give me for each one of these areas, for each one of these polygons, a summary of the raster values in that within that particular boundary. I can do that through zonal statistics. So zonal statistics is located under raster, and if you don't have it, I believe it also comes in as a plugin. Let's just see if it has it. So zonal, yeah. So there's the zonal statistics plugin. If you're not seeing it automatically, if it's not already loaded in, you can load it in. Okay. So we're going to go to raster, zonal statistics. And under zonal statistics, I just need to point it to my raster layer. So that's going to be my Australia clipped. And I want to collect now into my polygon layer. And if it doesn't see your polygon, try just reloading your polygon. So I'm going to just do a quick reload. So I'm going to go into exports, and I want my WGS and open it. See if it'll take it now. So if I go to zonal statistics, and it's still not seeing it. Let me try it one more time. Okay, I had to fiddle with that for a second. Sometimes that happens. So what I did is I just saved my project with everything removed that was a polygon, and then brought in the polygon that I wanted, and it finally saw it. So if you're having problems with the drop down finding it, just try to save it and bring your feature back in. So once I have it set up so it can see the raster layer, and then it's going to collect into the polygon layer for zones, I have some choices here, and here's the choices that I have. Essentially what I'm interested in is I'm interested in the sum, right? The raster value sum. I want to sum up all the values within each one of these areas to give me a total population count per administrative area. Remember, right now I just have a total population count per pixel, and within each one of these polygon areas I have many pixels, and some of them are really small, so I might even only have like half a pixel in some of those really small ones, but I want to collect those values up. So I don't need any of the other statistics really for this particular purpose. I just need a sum. And a count would also give me an approximation of square area, because we know that our cell size is close to 1 kilometer. But I'm just going to turn that off because we've already calculated square kilometers using our table calculation, our geometry column. So here we're going to go ahead and just give a statistic of sum back. And if you want to, you can name it. I'm not going to name this, and we can see what happens when I just don't name it. Or actually, maybe I'll say, how about I say total? So total sum, and I'm just going to say OK now. So it takes a second for it to go through each one of the polygons and actually do this collection process and give us back the statistic of sum for each polygon. Okay, so now if I come back here and I say open up my attribute table, I should see at the end, I should see a column now that says total sum. And we can see some of these are very small, so I have a very small number for my real small polygons. And then the ones around the city areas or the urban areas are going to be in the thousands. And then there's going to be a lot of them that are going to be just a very small number. Actually, let's sort on it here. So we have a lot that are, down in the 10s and 50s and 60s. These are going to be likely in the middle of the country where there's really low populations. There's a few of these that it's just not calculating any sum. We're not going to worry about those. And then we can see that we have some pretty dense areas also here. So that's great. We could go ahead and actually do the mapping for that total sum. But the problem is that if we were to produce a thematic map, we have two things going on. We have these really small polygons. So if we zoom in here, we got these really teeny tiny polygons. And then we have these really big polygons on the outside. And that size difference, we're not accounting for that size difference. We're not normalizing to the square area. And if we want to get a number, a rate that's going to make sense across the whole map, then we need to normalize for that square area. And we've done this in the past in normalization for population. So we take the total population and we use that as the denominator against our variable that we're interested in mapping. In this case, what we're going to do is we're going to take our population counts, which is our total sum statistic, and divide that by the square area. So we're going to now get a normalized number that's going to give us population density within that particular administrative unit. So let's go ahead and do that. So what we want to do is we want to open up the attribute table, and we want to create a new column here next to total sum that's going to take the kilometers and the total sum, and it's going to say total sum divided by kilometers. So let's go ahead and go into our field calculator. Let's create a new field, and we can call this something like pop density, popden. We can have it be a decimal number, and maybe 5 and a precision of 3 might work. And then for our field and values, we just go to field and values and develop our expression. So here it's going to be our total sum divided by square area, kilometers, and that's going to be the output. And we can go ahead and say OK. And it's going to toggle on. We'll say save layer edits. Okay, for some reason it didn't like saving it. So let me try doing that one more time. So on the second time it seemed to save it. And I'm going to toggle editing off and see what I have in my column here. So it looks like now I have a population density, and we can see that some of these are really small population density, but then we quickly get into some very dense tracts. And so these ones down at the bottom that are really dense, these are likely going to be in my urban areas. So let's just go, yeah, we can see that we have some really dense areas. And that makes sense, because if we click on and off, we can see that those particular administrative areas are sitting on top of extremely high dense population cells. Okay, so now what we have is for each one of our administrative areas, we can go into our table and we can see that we have three really meaningful columns now. So we have square area, so we know where our square area is. We know what the total population is for each one of those administrative areas. And then we also have a rate, the actual density that we can compare from one administrative boundary to another administrative boundary, regardless of the size of those administrative boundaries. We've taken out size out of the equation, and now we can just compare what's the density of population within these particular administrative units, regardless of the size of them. And this is the column that we want to actually map on as our final column here. So to do that, what we want to do is develop a thematic map now. So for the actual final turn-in of this particular map, we want to find a scale that's going to be appropriate. So if I were developing this, I would have it be somewhere around, looks like 20 million. Maybe I can get down to a little bit farther. Maybe 17 would work. Maybe even 15. Then I would set up my print composer. But before we would do all that, I'm just going to save my project. And then I need to find a thematic classification that's going to make sense. So let's go to Properties. And then I'm going to go into Styling. And under Styling, I'm going to go to Graduated Symbology. And my column now is going to be Population Density. Okay. And I need to pick a color ramp that's going to make sense. So I'm dealing with populations. Maybe something like this would work. And I need to then classify this. And so I can try a few different ones. I could do pretty breaks or standard deviation. I'm going to do quantile for this, and I'll explain why. I'm going to do quantile for Australia in just a second. And I'm going to have, let's just have 3 classes. So with quantile here, I'm basically setting up the equal number of features across each one of these for, it's an equal count of the values. So that's going to help me get an equal distribution across the map. That's going to help with this big difference in terms of these urban areas and then outside the urban areas. So at least at this scale, at like a say 17 million scale, I can see this pattern. So depending on your country and the pattern of the data, you may want to pick a different classification. So if I were to go to, say, natural breaks, let's try this. It gives me a map that's very difficult to read, because although it's shaped well to the actual data itself, I just lose these particular population centers in Australia using natural breaks. So even though natural breaks would fit the data quite well, if I push it to a quantile break, that's going to give me something that's going to be more evenly distributed, and it's just going to help at this particular scale make a meaningful map. So what this map tells us is that we have these population centers. It looks like there's 1, 2, 3, 4, 5 major population centers along the coast in Australia. We have some other areas that are interior that also are relatively high, but not as high as the coast. And then I can see that I have this interior area that is just really low population density. So this is my final map production, and again, Quantile works pretty good to describe this the dispersion of population density in Australia. So again, make sure that you're consciously thinking about the classification method that you make for your final map, that you produce for the final map. And just to recap what we've done, we originally started with cell values. Okay, so our original cell values, we've clipped that raster. We clipped it down to a project area, and then through working with the table, we developed meaningful square area for our administrative units, and then we collected the cell values into our administrative units. And so this is a common GIS process whereby we have continuous values, or sometimes discrete values, in the rasters, but the values we want to collect it up into some polygon container, or even into points. It's going to be some vector feature that we're interested in getting those particular values into, and this is kind of the process by which we do that, where we operate between a raster and a vector, and we're taking the values of the raster into the vector. Importantly, rasters are all about keeping one particular thing at a cell, which is one raster value at the cell, and that raster value always represents the theme of the particular raster.